We now talk about constant path. So you fix a point x in the space x, and depending on this point we can define a constant path. So the constant path means you just remain at that point x. So you just remain at point x. So you know that normal path, as t goes from 0 to 1, you go from say point x1 to x2. So at t equals to 0 you are at x1, and t equals to 1 you end up at x2. For a constant path you just remain at that point x. Now so if you are given a path u of t, you can immediately construct the path in the opposite direction, u bar of t. So to define u bar of t is very easy. You just take u of 1 minus t as u bar of t. So this becomes the opposite path. When t is 1, you are actually at u bar of 0. So you can see it is equivalent to traveling from x2 to x1. So again we will write it, say you go from x to y via path u. So path u bar means you're going from y to x. So a couple of results we want to prove is that first you travel u, then you travel u bar. This is homotopic to you remain at x. Similarly, first you travel u bar, that is go from y to x and then come back to y in the second half of the interval. This is equal to homotopic to that you remained at y itself. Other homotopies are, say u is homotopic to you first travel u in the first half of the interval, that is 0 to half, and in the second half of the interval from half to 1 you remain constant at y. Similarly, u is homotopic to in the first half of the interval you just remain at x, and in the second half of the interval from half to 1 you take the path u. So we are just going to prove this result. U is homotopic to first you travel u and then you remain constant at y. So the homotopy we are going to write is we denote by h subscript 1 t comma s. So you have u of 2t over 1 plus s, and where t lies between 0 and 1 plus s by 2. And then you have between 1 plus s by 2 and 1, the homotopy is just y. So this is actually very easy. You just plug in 0 for s. So you travel u in the first half of the interval, that is from 0 to half. And in the second half you travel from half to 1. So just plug in s equals to 0 and this becomes immediately clear. Then you plug in s equals to 1. I'm writing h1 t1. So you have u of t, and this is you have plugged in s equals to 1, so it is u of t. So you can sometimes draw a rectangle also. The horizontal side is s goes from 0 to 1, and vertical side is t goes from 0 to 1. So notice that t's first value here when s is 0 is half, and when s is 1, t you can see is 1. So there is only one value of t, that is 1 here. So you can see the two homotopy values we have taken on either side. So the first is u of 2t over 1 plus s, and then you have y here. The second we want to show is that you first travel u and then you travel the inverse path. This is homotopic to that you remained stationary at c of x. So for this homotopy you have h2 t comma s, you have x for t lying between 0 and s by 2. Then you have u of 2t minus s for t lying between s by 2 and half. So again you can just take 2t minus s and see that if it is greater or equal to 0, and less than equal to 1, how you rearrange them. And then u of 2 minus 2t minus s, t lies between half and 1 minus s by 2, and lastly you have x, you have 1 minus s by 2 less than equal to t, which is less than equal to 1. So again, this is very simple to see. You just plug in 0 for s and you get, for the first half of the interval from 0 to half, you travel path u, and then you get second half of the interval half to 1, you travel inverse path, and comma 1, if s is 1, then you just have x. Now x is in two parts, so first half of the interval you travel x, that is remain at x, and in the second half of the interval you remain at x. Now this is important because this information we used in drawing the this rectangle. So you have basically two values to look forward for, half and half. So for s equals to 0, you have to look for the corresponding value of t, so the interval changes at half, and at s equals to 1, again you have half, because this is the half right here, yeah, because you're remaining at x in two different halves of the interval. And then you just join them, join the endpoints. You have x here, u of 2t minus s here, you have x here, and u of 2 minus 2t minus s here.